function. Now, one thing about the tangent function, it has something like this. So if I graph the sine in, what you can see is that everywhere the sine is 0, the function is 0, because it is in the numerator. Remember, tangent is equal to sine over cosine. If I take the sine out, notice that everywhere the cosine is 0, we have these vertical asymptotes. And so it's undefined. So right now, because this is at 0, the cosine is 1 and the sine is 0, so we are at 0 here. Now if I move this point, you'll notice that I started at negative pi over 2, and when it gets to this, now notice what's happening is as the cosine is getting close to 0, which it is here, this thing is going off to infinity. And then all of a sudden at 0 it's an asymptote, and then it jumps and comes in the other side. And you'll see that it's every time the cosine hits 0, you get an asymptote there as it moves around like that. Now if I switch it for the sine, take the cosine out because it gets a little, right, and I go back, notice that every time the sine is 0, I'm crossing the x-axis. So the tangent and the sine are 0 in the same spots, like that. Of the tangent curve. So you'll notice that the amplitude really doesn't change it. It just gets a little steeper. It doesn't really move it. If it gets less than 1, it makes it more like a corner until it flips over to the other side and then moves away. So they're kind of the same kind of curve all the time. It's just kind of how much in the corner it goes. So that one doesn't do a whole lot. Moving it up and down looks like it does, because it makes it look like it's like there's like a wiggle in it, but really what's happening is this point where it crosses the y-axis just moves up and down. But really it's the same graph over and over. So that's what that one does. Now on the inside, here's where, notice the asymptotes, the purple dotted lines, I just put 2 of them in. They look, they never move with the a and the c, because they don't change the y values. They don't change with the change in the y values, but they do change with the x values. So if I want to stretch and squeeze the thing, if I make it bigger, it makes more per period, right? Changes the frequency, it's called 1 over the period, and you get more of them. So it does change where the asymptotes are, like that. And that's kind of a big deal. Now the d is the phase shift, and again, this just fixes them and slides them back and forth like this, right? So you just get those asymptotes, and that's kind of the key. You can't curve without talking about the sine curve, because of course every time the sine is 0, because the secant's the reciprocal, we're going to get asymptotes again. So as I move around the graph, as the cosine goes to 0, I'm getting an asymptote, right? And then also here where the graph is -1, the secant's also -1, because that's the reciprocal. And if I go to here at 0, notice that it's 1, because that's what the cosine, the reciprocal of 1 is 1. And again, it just follows it around as I move it across the graph like that. And every time the cosine's 0, here I'm backing up and forth like that. Curve, as we saw before, looks something like this. Now when we want to do the transformation, or just draw it in general, one of the things you want to do before you draw the secant curves, so let's get rid of those, is you would draw the cosine curve like this, which gives you the center line, the amplitude, and you can figure out what the cosine looks like. Now, because this is a reciprocal, every time the cosine is 0, I can put in asymptotes. Now I'm just going to stick 2 of them in here. And then what I could do is then at those spots I could then graph in the secant. So you get something like that, because now you know that it's just the reciprocal. So as you're going from 1, you know that these have to be the same, and as you get close to 0, it has to move closer to the asymptote. And so that's the way you draw the secant line. Now when you want to change the secant, right, and then you would remove it. You'd remove the cosine curve and all the other stuff that goes with it, and you would get the graph of the secant. Now let's put this all back in. Now so let's suppose that you want to do a secant, you want to change this. Well, again, draw the cosine first, because as it changes its amplitude, the secant's going to move away, because you're just getting those reciprocals, and if it flips over, you get the other way, that sort of stuff. It moves up and down. So you can see that the graphing the cosine is the key. Even the c, as you move it up and down, it's going to change where the secant is. Of course, that also changes technically the zeros, so that they're less frequent or more frequent or whatever, so that you could actually have zeros when you have something like that, because normally you don't have any at all. And then this one, these two, right, they change the period, right, by squeezing them and tightening, which changes the secant as well. So again, the key is graph the secant first. So let's see, I put this at 1. And again, the phase shift, right, moves it right and left like this. Just moves it right and left. That's the phase shift. Here you can see that the cosecant acts just like the secant. Where the sine is equal to 0, you get asymptotes, and where the sine is -1, you get the reciprocals -1. So you get these u's. They look like just like the cosecant, or yeah, just like the secant. This is the cosecant. And where the sine is 0, you have asymptotes. Where it's 1, you get the lowest spot, or of the u here, so that it's the reciprocal of 1 is 1. If you go to where it's negative, right here, reciprocal of -1 is 1. So they actually touch at those spots right there. Sine, just like the secant needs the cosine. So if I graph the sine in, say I want to graph the cosecant, if I graph the sine in with all its, I put in the center line and the amplitude. I don't really need to draw those. Every time I'm going to get close to 0, that means that my cosecant is undefined. So that means I'm going to have asymptotes there. So notice that I have asymptotes where the sine is 0. Now, as I get close to 0, I have to get close to the asymptote. At 1, the reciprocal is 1. So just like the secant, I'm going to get the little u's that sit above it. And then, of course, I can take out my, my sine curve, and I have the cosecant curve. Now, every time I draw it, no matter what it looks like, I would put in the sine curve first, and then I could do the transformations. And just like the secant, the sine is going to determine what the secant curve looks like. So if you change the amplitude, or if you change the period, right, or if you move it up and down, that's kind of the key, or move the phase shift, and you can get your cosecant curves. Cosine over sine. So I put these all in here because it's kind of where we left off with the tangent. But now notice that this time, as I move along, where the cosine is 0, we get that the cotangent is 0. And where the sine is 0, we're getting asymptotes, like this. And you can see as we move around, the cotangents match up with where the cosine zeros, and you're getting basically the same thing as the tangent, right? They are just 90 shifts on each other, cofunctions. Basically the same thing, where the sine is 0 this time, because remember, cotangent is cosine over sine. You have asymptotes. So as the sine gets close to 0, you're going to get these positive or negative asymptotes. In the first quadrant, both of them are positive, and then they're split, one positive, one negative, both negative, both positive. So you can actually see which side they're on. Where it's 0, oh, let's move the C here because this just moves it up and down the axis, right? So if I'm at 0, you can see where the cosine is equal to 0. That's where it's crossing. And of course, the C just moves it up and down that point along here, and you still get that same curve. The A is going to make it steeper or flatter depending on if it's bigger than 1, and then flip it over if it's negative. Just like the tangent. The B squeezes the periods or stretches them out, just like the tangent. And then the phase shift just moves the whole thing around. So when you're graphing these with phase shifts, you want to really determine where that sine and cosine are equal to 0, because one's going to give you the asymptotes, the other is going to give you the zeros.